Hey everybody, if you haven't figured out from the title, we are talking about my favorite, the moon. So we're going to start on the phases of the moon. So the moon goes through 8 different phases. This all depends on where the moon is during its orbit around Earth. So this is the fun part. The amount of time it takes the moon to orbit the Earth is 29.53 days. This is known as the lunar month. So as we know, all months are named differently, and some have more days than others, right? So a lunar month is always 29.53 days, so just over 29 and a half days. During this time, the moon goes from one new moon to the next, okay? So the phases start at the new moon and it will end at the new moon, okay? During this transition, the moon goes through its 8 different stages, and just like Earth, part of the moon is lit by the sun while the other part is left in darkness. And as a result, the angle the moon makes with the sun, that is how we see the phases of the moon. So, obviously, we're going to start at the beginning. We have the new moon. The new moon occurs when the moon is directly in between the Earth and the sun. It's going to look almost like it is in a perfect line, right? So at this point, the illuminated side of the moon is facing the sun, and the dark side faces us. And then we move to the waxing crescent. So waxing is growing, so the light is starting to grow, right? So during this phase, less than half of the illuminating side of the moon can be seen. It's considered to be waxing because every day after this phase, the amount seen of the illuminating side seems to be growing. After we get through the waxing crescent phase, we are brought to the first quarter. Now, most people think this part of the moon's phases are called a half moon, but it's actually not because we only see a quarter of it since we only actually see half of the moon at a time. So during this phase, the moon is at a 90-degree angle with respect to the Earth and sun. So if you look at this picture, the moon is at the top, Earth is underneath, and the sun is to the right. That would make an L, which makes 90 degrees, and that is the angle of the 3 in relation to each other. So we see exactly only 1/2 of the illuminated side of the moon, so that makes it a quarter. Then we get to the waxing gibbous. During this phase, more than half of the moon is seen. Like mentioned before, it is still considered waxing because a little bit more of the moon is seen every day. So unlike the waxing crescent, where we only saw the crescent, the waxing gibbous, there's only a crescent left that is not illuminated. Which of course then brings us to our full moon. During a full moon, the entire illuminated part of the moon can be seen from Earth. During this phase, the moon, Earth, and the sun are all in alignment again. As you notice, the moon is just on the other side, and that is why we see the entire side of the moon that is visible to Earth. So, now that we have waxed or grown, we are going to wane or get smaller. So we're going to go in the exact opposite order. So we have the waning gibbous. So just like with the waxing gibbous, more than half of the moon can be seen, but it's considered to be waning because every day the moon now seems to be getting smaller. And then after our waning gibbous, we have the last quarter. So just like during the first quarter, the last quarter, only half of the moon's illuminated surface can be seen. Then we get to the waning crescent. During this phase, again, only less than half of the moon can be seen, Like stated previously, it's considered to be waning because every day after the phase occurs, less and less of the moon can be seen. And then we get back to the new moon, right? So if you notice when you are looking at the sky, let's talk about the full moon, for example. That's a good place to start. When you look at the full moon, sometimes when you look up, you think, man, this moon has been full for like 3 or 4 days. It actually has not. It is gradually growing and then gradually getting smaller. It just happens in such a small fraction at a time that we don't notice it until it's a larger measurement. So that's why we only named the 8 phases rather than naming anything in between. So those are the phases of the moon, and I want you guys to pay very good attention to the video that I'm going to play, and then make sure you stick around and watch this whole video because there's going to be instructions on the end for your assignment.
Besides the sun, the moon is the most obvious object in the sky. Bright, silvery, with tantalizing features on its face, it's been the target of imagination, poetry, science, and even the occasional rocket. If you pay even the most cursory attention to it, you'll see that it changes every day. Sometimes it's up in the day, sometimes at night, and its shape is always changing. What causes this behavior? The moon is basically a giant ball of rock 3,500 kilometers across, hanging in space. Its surface is actually pretty dark, with about the same reflectivity as a chalkboard or asphalt. However, it looks bright to us because it's sitting in full sunlight. The sun illuminates it, and it reflects that light down to us here on Earth. And because it's a sphere and orbiting the Earth, the way we see it lit by the sun changes with time. That's what causes its phases. Geometry. The important thing to remember through all of this is because the moon is a ball and in space, half of it is always illuminated by the sun. This is true for the Earth, too, and every spherical object in space. Half faces the sun, half faces away. We call the part facing the sun the daylight or bright side, and the half facing away the night or dark side. The phase of the moon refers to what shape the moon appears to us, how much of it we see illuminated from the Earth. The key to all this is this line, dividing the lit day side from the unlit night side. We call that line the terminator. If you're facing the moon with the sun behind you, you're seeing the half of the moon that is fully illuminated by sunlight, and it looks full. If you're off to the side, you see half of the lit side and half of the dark side, and we say the moon is half full. If the sun is on the other side of the moon, you're looking at the unlit half, and it looks dark. Now, mind you, I haven't moved anything except our point of view here, so at all times, the moon is always half lit and half dark. Remember that. The phase of the moon we see depends on from what direction the sunlight's hitting it, and the angle we see that from Earth. The moon orbits the Earth roughly once per month. In fact, that's where the word month comes from. Month and moon are cognates, words that have similar etymological histories. And in most languages, including English, the two words are very similar. The length of time we call the month is derived from the length of time it takes the moon to go through all of its phases, 29.5 days. So, to describe the phases, let's start at the beginning. New moon. New moon happens when the sun, moon, and Earth are all more or less in a line. The moon's orbit is actually tipped a bit to the Earth's, so sometimes the new moon happens when the moon is below the sun or above it. But at some point in its orbit, at some point in the month, it appears to be as close to the sun as it can. What does this look like from the Earth? The moon is between the Earth and the sun. So from our perspective, we only see the dark half, the unilluminated half of the moon. The other side, the far side of the moon, is lit, but we can't see it. It makes sense then to call this the beginning of the moon's cycle, hence the term new moon. Now think about this for a sec. Because the moon is near the sun in the sky, it travels across the sky with the sun. It's up during the day. You can only see it from the part of the Earth that's lit, which is when it's daytime. It's a very common misconception that the moon is only up at night, but it's up during the day literally just as often. At new moon, the moon stays near the sun, so it rises at sunrise and sets at sunset. This makes it extremely difficult to see. It is, after all, sitting next to the brightest object in the sky, and only a little bit of it is lit from our perspective. But not for long. Because the moon is orbiting the Earth, after a couple of days, it's moved a bit to the east. Now we're seeing it along a slight angle, and we can see a little bit of the illuminated half of the moon on its side toward the sun. The terminator, the day-night line, appears curved around the moon, So what we see is a thin, illuminated crescent moon. At this point, the crescent is still very thin, with the horns of the crescent pointing away from the sun. Note that the moon is still pretty close to the sun in the sky, just a bit to the east, rising maybe an hour or two after sunrise. But this means it's up all day, and then sets after the sun does. This is the best time to see the crescent moon, when the sun is already set and the sky starts to get dark. The moon will be low over the western horizon, and it'll set soon after the sun does. Let's wait a couple of days. Okay, now the moon has moved a bit more in its orbit around the Earth, and is farther from the sun in the sky. We see a little more of the illuminated part, and the crescent is wider. Since it's getting thicker, we say this is a waxing crescent moon. Waxing means growing or getting bigger. It's also well away from the sun now, so it's easier to spot even during the day before sunset. 7 or so days after new moon, we get to our first milestone. The moon is now 1/4 of the way around its orbit. It's 90 degrees away from the sun in the sky, which means we're looking straight down on the terminator, the moon's day-night line. It cuts right down the middle of the visible face of the moon, so it's half lit, with the sunward side of the moon visible and the other side dark. Confusingly, this phase is properly named first quarter because the moon is 1/4 of the way through its cycle, 1/4 of the way through its orbit around the Earth, even though it looks half full. So it's not really the half full moon. Astronomers prefer first quarter. So if you want to sound all astronomery, then you should call it that. But time marches on. The moon continues on its gravitational dance with Earth, swinging around its orbit. Now more than half full, we say its shape is gibbous, which means swollen or convex. Since it's getting wider, this is actually the waxing gibbous phase of the moon. It rises in the late afternoon and is up most of the night. Our next big step comes 2 weeks after new moon, when it's moved halfway through its orbit. It's now opposite the sun in the sky, 180 degrees around. The Earth is between the moon and sun, so we're looking at the fully illuminated half of the moon. This is the full moon. Because it's opposite the sun, it rises at sunset and sets at sunrise. It's up all night, shining down on Earth. But again, wait a couple of days and things change. When the moon is full, it's 180 degrees around the sky from the sun. So as it continues to move around the Earth in a circle, the distance between it and the sun is now starting to decrease, even as it continues on in the same direction. As before, it keeps rising and setting later, but now it rises after sunset and sets after sunrise. If you get up early in the morning as the sun is just rising in the east, you'll see the nearly but not quite full moon setting in the west. Not only that, but we're about to go through all the phases again, but in reverse order. A few days after full moon, the lit side is shrinking. It's in the waning or shrinking gibbous phase. Then, 3 weeks or so after new moon, and a week after full, the moon is once again half lit, the terminator splitting the moon's face in 2 even halves. This is the third quarter moon because the moon is 3/4 of the way through its cycle. It's a lot like first quarter, but the side that was lit is now dark and vice versa. It's 270 degrees around the sky from the sun. It rises at midnight and sets at noon. A few days later, and the moon is a crescent again, getting thinner. It's now a waning crescent. It rises just a couple of hours before sunrise and sets a couple of hours before sunset. Then, finally, we're back where we started. 1 month after new moon, the moon has traveled 360 degrees around the sky and is once again as close to the sun as it can get. It's new moon, and the cycle starts up again, as it has for time immemorial. An interesting thing happens if you move your perspective from the Earth to the moon. The phases of the moon we see from Earth depend on the angle of the moon and the sun in the sky. But on the moon, the angles are exactly 180 degrees reversed. At new moon, when the moon is between the Earth and sun, the Earth is opposite the sun as seen from the moon. It's full Earth. All the other phases are opposite too. So when we see a full moon, a moon dweller would see a new Earth, and so on. Have you ever looked at the thin crescent moon and seen the ghostly face of the rest of the unlit side? That's because it's not really unlit. The nearly full Earth is reflecting sunlight on the moon, lighting up the otherwise dark part. The Earth is bigger and more reflective than the moon, so it's actually 50 times brighter than a full moon. This glow is called Earthshine, a term I quite like. Even more poetically, it's been called the old moon in the new moon's arms, referring to the unlit part surrounded by the crescent new moon's horns. That's lovely, isn't it? The moon is one of the most beautiful and most gratifying objects in the sky to observe. It's different every day, yet it's also the same because we see more or less the same half of it, the same face all the time. It's big and bright, and the features on its surface discernible by eye, and even better with binoculars or a small telescope. As the phases change, inexorably, day after day, the angle of sunlight hitting the surface changes, bringing new things into our view. The motions become comforting, even familiar. It's a reminder that the universe may seem strange and complicated and forbidding at first, but over time, as you get outside and experience it, it becomes your neighborhood. Welcome home. Today you learned why the moon has phases. It's a sphere and it orbits the Earth, so the angle at which we see its lit side changes. It goes from new to waxing crescent to half full, waxing gibbous, full, waning gibbous, half full, waning crescent, and then the cycle starts all over again. This also affects when it rises and sets and what we see on the surface. Crash Course is produced in association with PBS Digital Studios. This episode was written by me, Phil Plait. The script was edited by Blake DiPastino, and our consultant is Dr. Michelle Fowler. It was co-directed by Nicholas Jenkins and Michael Aranda, and the graphics team is Thought Cafe.
So I hope you enjoyed your little video there. Hopefully that helped answer any questions that you might have. If it did not, please send me an email or a Hangout or a Canvas message or a carrier pigeon. I just want to make sure that you guys fully understand this. To help do so, this is your assignment, this is your project, this is the Phases of the Moon Interactive Project, okay? So what you're going to be doing is filling in the missing pieces for this slideshow, okay? So let's take a look at it. So what you're going to be doing is, on this slide, the directions are written down here. You're going to use the Explore tool if you need it, which is this tool right here. If you click on it, it opens up this search window, and you can type in like what happened? There we go. Type in moon phases, right? And it will pull up stuff on the internet for you. If you click on images, if you look right here, it gives you exactly what you're looking for, right? So that can help you answer these questions. If you need it, I suggest trying it without it. But if you need it, go ahead. So what I want you to do is I want you to drag these descriptions under where they belong in the moon cycle. So you can either like put them underneath, or you can put them on the moon, or you can put them however you want to do it, as long as I know what you are trying to tell me, okay? So that's for this first slide that you're doing. The first one obviously is just the title. The second one, like I said, you're going to label each phase of the moon. Then you're going to come down to this slide, and as you can see, all 8 phases are written here. I want you to click in this text box, and I want you to find 3 facts about each phase and write them in here. You can make them organized by putting them like with bullets or numbers or however you want to do it. But remember, this is a project grade, so I want you guys to like work hard on it and try. Please don't just like, you know, throw crazy little things in here. I want you to be learning about the moon phases, okay? So find 3 interesting facts about each phase and put them in here. And then for the 4th one, the descriptions are here, but the moons are missing. So I want you to do kind of like what you did in the other one. I want you to grab a moon and put it where it belongs, okay? For the 5th one, you're going to use the shape tool. So if you go up here to insert shape, okay, and there's all these shapes, and I want you to create your own phases of the moon. You can use any shape you want. They don't have to be circles. Get creative. This is your project, okay? So go ahead and do your phases with the shapes, and then make sure you label each phase with the correct name. And then in the last one, you're just going to type them in, okay? So hopefully this repetition will help you remember each phase of the moon, so that way when it comes to a test and I throw this guy on there, right here, you know exactly which moon that is, and you can just type it in, okay? So this is your project. Again, it's worth 40 points. Please make sure you are trying hard on it, okay, guys? And you have until the 12th to complete it, so you have plenty of time. to work on these and to get information and to research, okay? So if you have any questions, please reach out so I can help you. Otherwise, I hope that you guys enjoy completing your project, and I can't wait to see them.